charge is a property that a molecule, particle, or an object can have. So it will experience a force in an electric field. So particles can have an electric charge. Electrons are negatively charged. Protons are positively charged. So we measure charge in coulombs, which is a big C. And basically, an electron has a charge of this many coulombs. But a simple way to write it is 1e. So where E is in standard form 1.6 times 10 to the minus 19 coulombs. So in an atom, our atom overall has no charge. We've got our three particles that make it up: a neutron, which has absolutely no charge, found in the nucleus, a proton, which has a positive charge of 1e, and an electron, which has a negative charge of 1e. So we've got atoms can gain or lose electrons, and then that results in our atom becoming an ion and gaining a charge. So if an atom loses an electron, it becomes positively charged because our electron has a negative charge. And if we lose that negative charge, we've got a positive ion. So you can just see here, the atom, it's lost one of these electrons and it's become positively charged. And just note for exams, the way that we're going to draw this. So you'll see this in chemistry as well, how you draw these square brackets around and you write your charge in the top right corner. So if this was, say, 2 plus, say if it had lost 2 electrons, we would write a 2 plus next to it, say if it had lost both of these. So we'd write that in the corner. So, and if it gains an electron, it becomes negatively charged because we've gained something that's got a negative charge. So an atom gains 2 electrons. What overall charge has the ion formed? Okay, so let's have a look. So yeah, most of you getting it right. It's just to keep note. So the second most popular answer was +2. But if it's gained 2 electrons, I had to think about that then, whether I got the question wrong. But if we've gained 2 electrons and they're negatively charged, I can't type right on here, I think. But if we've gained 2 negatively charged particles, we're going to have a negative charge overall. So just don't fall into that trap for your exam questions. Okay, so electric fields. Electrically charged objects create electric fields around themselves. If another charged object enters this field, a force acts upon it. The further an object is away from a field, the weaker the force is. So that makes complete sense. If you're far away from something, you're not going to feel the full effects of that field. Electric force is a non-contact force, which means that without physically touching the object, it can exert its force upon it. So, recap of electric fields. We always draw our field lines moving from the negative charge away from the charge. So our field always moves from negative to positive. So if we can keep that fact in mind, our arrows will always move away from a negative field and towards a positive field. So you can see how we've drawn our arrows. And then if we've got objects are both negative or both positive, they will repel each other. So we can see that here's our field lines pushing away from each other. And that's why when you think of magnets, that's why they push away from each other. And they, keyword for your exams, say repel, they repel each other. And if we've got opposites, they will pull each other together and they attract. And remember that that's because our forces always travel from a negative to a positive. So we can literally just draw a straight line. You can see this is exactly why opposite charges attract and like forces repel each other. So would particles with opposite charges attract or repel each other? Oops. There we go. So yeah, everyone getting it right, nice and easy. Let's go. So we've got electrical conductors. So not every material allows a flow of electrical charge. So a material that can allow for charge to flow is an electrical conductor. And materials that do not allow charge to flow are called insulators. So a material that allows current to flow allows for the flow of electrons. So that's exactly what current is. It's the flow of electrons through that material. So usually these are metals and our insulators, if you can think of a couple examples. I've got my question now, which are not electrical insulators? So think about what I just said. If charge is the flow of electrons, you're kind of thinking of what doesn't really have free flowing electrons. Let's see. So yeah, you guys, this is just a trick question. So in a way, so I think you guys might have seen the question before and the answer was, it was different. I think for some reason it had the wrong answer. So I feel it might trap some people. But if you think back to chemistry and how a metal is arranged, it's got a sea of delocalized electrons, if you remember that from your exam answers. So those electrons in metals like iron, copper, and gold are free to flow and they can carry charge, whereas in glass and plastic and wood, it doesn't really have the availability of those electrons that can just freely move around inside. So that's why that's an insulator. But yeah, trick question. So static electricity next. So usually due to friction, we get a charge accumulating on an insulated object. So static electricity does not work for conductors. Why is this? Because there is no buildup of charge. They are able to conduct that charge. The electrons are able to move and conduct that charge. So an example, when you rub a balloon with a sweater, the balloon can stick to surfaces. So as you can see, when you're rubbing this balloon to the sweater, you've got a transfer of electrons. Which way? Just have a quick think of which way are the electrons moving? Are they moving from the sweater to the balloon or the balloon to the sweater? So electrons are moving this way because we're gaining a negative charge. So if our electrons have this negative charge, the thing that's becoming negatively charged is what's gaining electrons. So there's a transfer of electrons from the sweater to the balloon, and that's how we get that static buildup of charge. So we've got another question now. So we've got two polystyrene balls, A and B, are shown below. Both balls are charged, ball B is positively charged, and the diagram shows what happened when ball A is brought near ball B. So you can see what is happening. Ball A is charged. Describe one method by which ball A could have been charged. So if you want to write down your answers either on a piece of paper or you want to put it in the chat function, and we'll go through them in a minute. If you want to do, if you want to prepare for all three, I don't know how my answers are going to come up, so I don't want to reveal the answers too early. So first question, describe a method by which ball A could have been charged. Part B, is ball A positively or negatively charged? Explain your answer.
Hi,
Hi.
teacher.
Hi. Yeah.
We can see you checking out the Q&A at the moment. It's not staying on the presentation. Just so you
Yeah,
know.
no problem. Okay, thank you. Someone just said, can we slow down? Okay, sorry. I realized I was going a bit faster. I will slow down a little bit. If there's anything you want me to recap at the end, then just let me know. If there's anything you need me to recap, but okay, so hopefully everyone's, at least with part A, everyone's feeling ready. So, oops, yeah, everything comes up. I'll give you another minute then we need all three parts done. So describe one method by which ball A could have been charged. Is ball A positively or negatively charged? And ball A is moved closer to ball B. Which way does ball B move? So, so one way that we can charge the ball, is by rubbing it or by friction, like we said. So the exact way that we charge the balloon, by rubbing, by creating friction, we can charge the ball. And then ball A, I think the question was, is negatively charged. Why? Because there's clearly an attraction between the two. We can see that the ball is moving towards the other one. So clearly there's attraction. And we know that our opposite charges attract. And then if we move the ball closer, what's going to happen? Well, they're attracted to each other. And if we bring the ball closer, what happens? We said that as we get closer, there'll be a stronger force of attraction. So they'll move forwards, they'll move towards A, or they'll move to the left. You could have said either one of those and you'll get your marks. So we'll try part D. Kevin rubs the whole surface of two strips of the same plastic with a cloth. He hangs strip X on a nylon thread. Then he brings strip Y near one end of strip X. So describe what will happen to strip X and explain your answer. So I think both questions are going to come up together again. So as well, let's do part E. Describe what will happen if Kevin brings strip Y near the other end of strip X and explain your answer. So I'll give you maybe 2 minutes for this question. Okay, so describe what will happen to strip X and explain your answer. So we've rubbed the whole surface of the two strips with the same plastic, with a cloth. And now we're bringing strip Y to strip X. What's going to happen? That is not good. I cannot see my own answers. I'm sorry, before the session, I was just moving stuff around, so I just didn't put it back. But here is the mark scheme. I'll just make it bigger so you guys can read it. So anyone they will be repelled, they'll move away from each other, or possibly it would spin. I would always say repel because we're talking about charges, or move away, but I think using the word repel is probably the best option. And why are they going to be repel? Because they both have the same charge. If we've done the exact same thing to the same plastic, they're both made of the same plastic, we've used the same cloth, they're probably going to have the same charge. So they're going to repel each other. And then we've got the second part of that question. So describe what will happen if Kevin brings strip Y near the other end of strip X and explain your answer. And here we can see it will also be repelled, it will also move away, or it will spin. Do not expect it will spin away from Y. So you can see the examiner wants us to be really specific. So just saying spin is not acceptable. We have to say away. So I think the best option and what I would do, just to guarantee those marks, always say it will be repelled and move away from Y. So say what kind of force is being exerted, repulsion, and which direction is it going to move away from Y. Why is that? Because they have the same charge over the entire surface. So he did say that he's rubbed it over the entire length. Yeah, the whole surface. So the whole thing is charged. We know that it's going to have the exact same force. I think it can be a little bit tricky. I know that I might have been thinking maybe I'm doing something wrong if I'm writing the same answer, but don't ever be put off. You know your facts, so be confident in your answers. And then we've got another one. So the diagram shows a polythene rod being rubbed with a woolen cloth. Polythene rod becomes negatively charged. Can you explain how this happens? So I'll give you about a minute for this one. But try to include all your keywords. Think about, I won't say anything, actually, I'll say all that. But try to use keywords. Okay, so we've got a polythene rod being rubbed with woolen cloth. The polythene rod becomes negatively charged. Explain how this has happened. So we've had electrons being transferred. So try to say, when I was saying about keywords, try to point out literally everything that's happened. So why do we get a charge? The electron transfer from the rod to the rod from the cloth. So I don't know if it actually tells you. Yeah, so it tells you that it becomes negatively charged, the rod. So you know that now this rod has a negative charge because you've rubbed it. So if electrons have been transferred to the rod, you know that there's been a transfer from here, and this has got a positively charged now, a positive charge, sorry. So electron transfer from the cloth to the rod, to the rod. Yeah, perfect. And then you get all your marks. Another question. So a student put the charged rod onto a balance. The rod was separated from the metal pan of the balance by a thin block of insulating material. The student then held a second charged polythene rod above, not touching it, and then the reading on the balance increased. Explain why the reading on the balance increases. So we put a rod onto the scale, and then we're holding another rod just above it like this. Why is the reading increasing? And then part 2, because our answers are probably going to come up together. The student observed that the nearer the two rods are to each other, the bigger the increase in the balance reading. So as he moves this closer, this number increases. What should the student conclude from this observation? So I'll give you about 3 minutes. So if you can just write exactly what you'd write in the exam. Okay, so hopefully you're ready. So explain why the reading on the balance increases. So we've got the rods repelling each other. So we've got two rods with the exact same charge. So we just gave them a negative charge. So if we hold something here with a negative charge on it as well, our like charges are going to repel each other. So they're pushing away from each other. So if you can think about that, we've got this basically pushing this way, this pushing this way. So this rod pushes down on the scale, and that's why the balance increases. So we've got a downward force. So we're pushing downwards on the scales. Do not accept increasing the weight or mass, because we have to be quite specific in what we're saying. And the rod actually doesn't increase in weight. We're not putting anything else on the scale. So weight or mass actually doesn't change. It's this force. It's like pushing down on the scale with your fingers almost. You're like kind of cheating. You're pushing something with extra force and giving a false reading. And then for the second part of the question, as we move the rod closer, the weight increases. So you can see first it was 100.25 and now it's gone to 102.5. So like we said earlier, as you move two electrically charged objects closer together, the charge, whether that's repulsion or attraction, is going to be greater. So as you move them closer together, this repulsion charge gets even greater. So they're pushing away even harder. So this downward force becomes even greater. And that's why we get an apparent increased reading from the scale. So the repulsion force increases as the distance decreases. So, as we said earlier, current is the flow of charge. It's the flow of electrons in wires. This is the flow of electrons, and current always flows from positive to negative. So if you want to make a note of this, because it's going to come up. So always from positive to negative. So to make a current, you will need a battery. So this is going to give our electrons energy and allow them to move, basically. And you need a complete path. So say a loop of wire, and you need this to be complete, being the key word. There can't be any gaps, otherwise our current can't flow. So here we go, we've got the simplest circuit that we can make. So we've got our cell, and then we've got the current moving from always positive to negative, so it's flowing in this direction. And then we can add a component in, so in this case we put a lamp in to that circuit, and you can see that as the current flows, our battery, our cell, gives that energy, our current flows, turns the light on, and then we get that current flowing to complete the circuit. So the wires in most circuits are made of copper, which is surrounded by plastic insulation for safety. Some wires are made of more expensive metals, but copper being a very good example. If you're ever asked in an exam for an example of a metal that's either a conductor or good for wires, use this. So here are some of our circuit symbols. We're going to be seeing them in quite a lot of questions that are coming up. So if there's any that you want to note down now for later. So for the cell, the way that I always remember to draw my cell is I always start with positive to negative, just like the way that the current will flow. And the way that I remember that the positive side is the longer side is like if you open.
Sorry, I didn't get that. The internet isn't.
My Alexa is playing up. The way that I remember it is, so my positive side is like opening up your plus sign. So you would have, if I open up my plus sign, I would have a longer line. Everything's playing up now. I would have a longer line, and then on my negative side, like a negative sign is just really tiny. So that's my tiny side. So that's how I remember which way around I'm going to draw it. Always positive and negative. Remember that a battery is just multiple cells added together. So if I literally just got two batteries and put them together, if I've got two cells and put them together, I'd make a battery. Remember a lamp and switches. And then you really want to be remembering these because they're coming up in quite a few questions. If you want to note them down, or if you can remember them, that's great. And then we've got our resistors and a buzzer. And I always used to forget the buzzer, so I would note that down. So like we just said, a single battery is actually called a cell. So I think that commonly around the house, we just call a single thing like this, that's like your AA battery, is actually a cell. It's a single battery, basically. And when you put many of them together, you make a battery. So the shorter side is a negative side, and the longer side, your positive side. And just take note of, like, if you ever have to draw multiple cells, this is how you draw it. And then you can even continue this on. So say if they give you a question in your exam that says three cells together, or three batteries, basically, you can literally just continue this. I don't know what's happening today. Nothing's going right. I think you can get what I'm trying to do. But here is me trying to draw a battery with my pen that's not working. your switches, they stop current from flowing. So remember how we said that for current to flow, you need a complete circuit. You're literally just opening up your circuit and current can't continue past this point. So, and just a key thing to remember for your exams is that your examiner really wants to have straight lines. So where you can, use a ruler, because sometimes they might not be too happy if you use if you freehand it. So in series, this is a term that we use to describe a circuit that's connected with each component in turn. So you can see how we start off with our cell, and then we're flowing from positive to negative. So our current flows this direction through each lamp and then back to the cell, and it looks like one big loop. Okay, but you can also have circuits in parallel where you basically got multiple paths, so we can flow through each component in turn. So it's almost like we've got different parts of the circuit. Basically, it's got different loops. And then we've got complex circuits, which have a mix of in series components that are in series. So these two lamps are in series, and this is in parallel. So draw a circuit that has a motor and a lamp and can be switched off by the same switch. So we'll do the first one together, I think, and then each other question, I think I'll give you guys a chance to complete it first. So how I would approach this question: draw a circuit that has a motor and a lamp that can be switched off by the same switch. So start off with your cell always, and then I might not actually put my switch in first because I want to plan out where my components are going to go. So we're going to put our lamp in, put our motor in, and then this switch here, if you can see, if that got turned off like it is now, no current can flow past this point. So the whole circuit is broken basically. This switch is not the best, because if we had this as a closed switch, actually this circuit is still complete, the first circuit. So this current will still flow, the lamp will still be on. So if you had this question in an exam, I would go with the safe option of putting my my switch in a location where I know for sure it's going to turn off both components. So next question, if you guys want to have a go at drawing this, draw a circuit that has a motor and a lamp that can be switched off by the same switch, and the motor can be switched off separately. Actually, don't bother with that one, it's exactly the same. So I think we didn't actually, this one, like I said, the last question, this one shouldn't have been here. But yeah, that's the right answer for that. And then this one, so like I said, the motor could have been switched off separately with this diagram. So yeah, if you open up this switch, you switch off everything. And if you open up this switch, you're only turning off your motor. Still, if this was closed, you can see that current can still flow along this without being disturbed. There's a complete circuit here. So that's why that lamp can be on and this can be off. So, are the motor and buzzer in series or in parallel to each other? So if you could just get back on that Slido to answer this question, please. Okay, let's see the answers. A lot of you saying in parallel, a couple of people saying in series. So the answer is that they are in parallel. So I think somewhere that you could easily get maybe mistaken in this question is, so our buzzer is at central, this is our buzzer, and this is our motor. So I might have got mixed up myself by maybe looking at the other components, but always remember your symbols first of all. So I would maybe literally, as I'm reading through, it's talking about the motor, I'd maybe put my pencil on there just so I know what I'm talking about. Buzzer, and you can see that they're in parallel to each other because there's basically two loops of the circuit and they're in different loops to each other rather than being in a straight line. So in parallel. Okay. Now we're going to talk about the dangers of electricity. So we've got, there's a chance of charged objects giving you an electric shock, which can cause burns, and they can be quite dangerous for your heart. They can cause your heart to stop beating. I mean, I don't know why this question is here, but we'll go with it anyway. Susan has a small fan to keep herself cool, and when she switches it on, a motor turns the blade to blow air. So here are your symbols. It's given you them in this question, which is quite nice. In the space below, or wherever you've got space, draw a series circuit diagram for the fan using these symbols. So if you want to have a go, just remember straight lines. You've got the components here. So I'll give you about a minute to draw that if you just want to do a quick diagram. Okay, so hopefully you've all had a go at this question. So here's an example. You could have put your switch in a different location if you wanted to. You could put it here, here, here. It doesn't really matter. If you open up this switch wherever it was, so you could have positioned it on this side, over here, it would still break the circuit and it would still stop the motor from working, so it doesn't really matter. But as long as you've drawn a battery and not a single cell, just make sure that you're paying attention to how they want you to draw each component. But yeah, hopefully you got that. You felt okay about that question. So complete the sentence below using the words listed below. When the blades are turning, energy is wasted as something energy and something energy. So chemical and heat, chemical and light, chemical and sound, heat and light, heat and sound, or light and sound. Okay, so most people saying heat and sound. That's the right answer, yes. So I think I would try to visualize, if I was trying to answer this question, maybe in an exam, I try to think, okay, well, this is an object that you're likely to be familiar with. What actually, what are the energy forms that are being wasted? So when you have a motor, usually becomes hot. That's quite a safe option. And you know that a fan is usually quite noisy, so that's also a safe option. Chemical, there's no sort of chemical being formed, so that's why that one would be wrong. And unless there's, you know, some sort of light being emitted, there's no lamp as a component, sorry. So it's unlikely that there's light being produced. So heat and sound are safest options for our wasted energy. So which part provides energy for the circuit? 1 mark, nice easy mark. So some of this energy is used to turn the blades. The rest of the energy is wasted. Complete the sentence below. When the blade's turning, energy is wasted as what? So we already know the answers. I'm not going to make you go through it. So our battery provides energy for the cell. And then we've got the blade turning energy is wasted as, like we just said, heat and sound energy. So we've got current being the flow of charge, which is measured in amps. And this is our sign. It's a capital A, always capital. I've seen in some mark schemes where the examiner said that if anyone uses a lowercase a, they're not getting the marks. So always capital A. And when you're drawing your sign, remember always a capital A inside that. So when you're drawing your ammeter. So ammeter must be connected in series with that component if you want to measure the current that's flowing through it. Okay, so remember in series. So what we've done to put this ammeter into the circuit, remember that our current flows from positive to negative, so it's flowing in this direction. We'll put our component, and then after that, whatever component we want to measure, we'll put the ammeter after that. So it can measure the current that's flown through it. So our current's going this direction. We can measure what's coming through it. It does not measure current across the lamp if it's in series with it, which is different to a voltmeter, as we'll see in a bit. But remember, in series for measuring current. So if we add more cells, we increase the current. And if you think about that, current is the flow of electrons. So if we say that these are our little electrons and they're traveling from positive to negative, so they're flowing in this direction. If we give more cells, if we put more cells in that circuit, we have more energy. More energy forces these electrons along faster. So we're increasing the current, we're increasing the rate these electrons are moving. And if we take away cells, we decrease the current, so that makes sense. An increase in current will increase the brightness of a bulb. So here we can see our bulb with 0.5 amps. Here we've added another battery and we've put the current at 1 amp, and you can see how much brighter the lamp is shining. So what is not true about current? Is current measured in amps? Is current measured by an ammeter? Does current flow from negative to positive? Or current is the flow of electrical charge? Which of these is not true about current? Okay, so which of these is not true about current? Current flows from negative to positive. That is not true. What have we been saying? Current flows from positive to negative. We do measure current in amps. It is measured by an ammeter. That was the component that we just saw back here. So this is an ammeter, and that's measuring current, and current is the flow of electrical charge. So, wrong answer. So, current in series. So, in series describes a circuit that's connected with each component in turn. The circuit will look like one big loop, and you could follow it through. You could follow your circuit through with all the components without lifting your finger. So current is constant in a series circuit, and wherever you put your ammeter, you would get the same reading. Okay, so try to remember that. The more components you add, the lower the current will be on the whole circuit. So there are some advantages of a series circuit. So you need fewer wires. You're just making one loop, so fewer wires, and they don't get heated as easily. So you're less likely to cause fires, because fires break out when you've got overheated components and overheated wires. But a disadvantage is if one component breaks, the whole circuit's broken. So like we said, it's one big loop. So any break in that circuit breaks the loop, and none of your components will work anymore. So when you've got current in parallel, this describes when your circuit has two loops, like we said earlier. It's like your current divides, and you've got paths that reconnect, and there are many loops. So current gets shared in a parallel circuit, but it's not always equal, and that depends on the resistance of the components. So when two identical components are connected in parallel, they equally share it. So I found this quite confusing when I first started learning about physics, but just remember, when you've got a circuit in parallel, you don't always share your current equally. But when you have identical components in a parallel circuit, that's when you'll share your current equally. So in an exam, always look for them to say that the components are identical. They usually will if they are, and sometimes that's a trick question, and it can make you lose some easy marks. So let them tell you something is identical rather than assuming. But here we can see we've got two lamps that appear identical. They are sharing the current equally. Okay, and the total amps in this, the total current in the circuit is 1 amp, which is divided by 2. So, unlike series circuits, if a compound breaks or is disconnected, only that loop stops working, and everything else can keep working. So what would happen if lamp C broke? If you want to put it in the Q&A. So if this component broke, what would happen to B? What would happen to A? So if C broke, B and A would still be able to work. Current could still flow through this. So it's like what I showed you guys earlier. So if you can draw a line through your circuit without lifting your finger up and there's no breaks in the circuit, that will still work. Here, we've got a break in the circuit. This is not working anymore. So imagine this is almost like, this wire not being here. I can't get past this point and continue the circuit. So broken, but these two can still work. What would happen if lamp B broke? Which components would still work and which would stop working? So again, you're trying to find one, like a path. You're trying to look for a path that you can still travel through without breaking the circuit. So there is a loop that you could go through, even without this lamp working. So you could travel through here, 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 and here, and everything would still be working. And what if lamp C broke? We've already done that. That, I think what they meant on this question was, what would happen if lamp A broke? And if this isn't working, we can't get back to our negative side of the cell. So if you can see, if we went this way, nope. And if we went this way, nope. So if lamp A broke, we've broken the entire circuit and we can't, none of our components will work. So Lonnie makes a series circuit with 3 identical lamps. What will happen to the brightness of the lamp if she removes one? So will the brightness get dimmer? Will it stay the same, or will it get brighter? So if she removed one lamp, then the remaining lamps will get brighter. So remember what we said about a circuit in series? We have each component sharing the current equally. So if we had 3 lamps, and if we remove one, we were sharing that current 3 ways, and now we only have to share it 2 ways. So we're going to have a brighter lamp.